a completely unexpected move. At this moment, the machine has surpassed the human master.
Welcome to this explainer. Today, we're not just, staring at lines of code or cold silicon chips. We're looking at a story of absolutely breathtaking awe, high stakes, and honestly, a deeply profound yearning that goes to the very core of what it actually means to be human. We're talking about the quest to literally create a mind. It's a journey that's packed with spectacular triumphs, for sure, but also with some crushing, deeply human heartbreaks. To truly feel the weight of this story, I want you to cast your mind back to a very specific moment in time. Imagine the collective, held breath of 200 million people. It was 2016, and across glowing screens all over the globe, there was this palpable, heavy tension in the air. Millions of people were watching live as a machine achieved something that the world's absolute most brilliant experts had confidently insisted was still like a full decade away. Why? Simply because this specific game requires something machines weren't supposed to have: intuition. The atmosphere was just electric. The setting was a quiet hotel room in Seoul. In that room, an AI system called AlphaGo sat across from Lee Sedol, who was the reigning human world champion of the ancient game of Go. And then, it happened. Move 37. AlphaGo made a play so entirely unconventional, so utterly alien to human strategy, that professional commentators watching live actually stumbled over their words. They initially assumed it was a glitch, a mistake, a machine error. But as you'll see, it was definitely not an error. To put this into perspective, compare the number of atoms in our entire observable universe to the number of possible board positions in the game of Go. The board positions actually outnumber the atoms. No way, right? In a game whose complexity absolutely dwarfs the physical universe, Move 37 wasn't a miscalculation. It was an expression of pure, breathtaking strategic foresight. In that singular, stunning moment, an emotional realization hit the world like a ton of bricks. This wasn't science fiction anymore. The theoretical, distant pursuit of the world's smartest AI had suddenly, irrevocably, become very, very real. The starting gun hadn't just been fired, the race was already well underway. And the implications were massive, right? It directly set the stage for the algorithms that currently curate our news, run our financial markets, and quietly shape our everyday modern lives. Humanity was suddenly scrambling to catch up to its own creation. Okay, let's dive into this. Section 1. A centuries-old human dream. The long quest for artificial beings. Let's trace the long, really poignant history of this dream, which actually begins 2,700 years ago. The quest to create machine intelligence is way older than most people realize. Think of the giant bronze automaton Talos from ancient Greek myth, who was constructed to protect the island of Crete. It's a desire that has lived quietly and persistently in the human heart long before electricity was even a concept. The modern pursuit, though, began with a tender, hopeful earnestness during the really dark days of the World War II era. It was a time when the distinct fields of neuroscience and computing first sort of collided. Over in Britain, brilliant minds like mathematician Alan Turing and neurologist Gray Walter gathered in an influential dining society known as the Ratio Club. Over meals and drinks, they traded ideas, diving deep into cybernetics and trying to map biological neural networks onto rudimentary circuits. They were building some of the very first physical robots, laying this quiet foundational groundwork for understanding the human mind by trying to mirror its physical structures in machines. From this fertile ground emerged a concept that still totally echoes today: the Turing test. Also known as the imitation game, this wasn't just some basic technical benchmark. It was a profound, philosophical attempt to measure the very essence of human-like intellect, the soul of a machine, if you will. Turing proposed that if an evaluator couldn't tell the difference between a human and a machine in a text-based conversation, well, the machine was exhibiting genuine intelligence. It was a criterion designed to answer a beautiful question. At what exact point could we interact with a machine and recognize true artificial thought? Section 2. The ambition of 1956, naming the dream. Now, what's really interesting about this slide is, it brings us to 1956. A young, visionary computer scientist named John McCarthy stood up and audaciously coined a grand title: artificial intelligence. Two simple words that captured a monumental leap of faith and human ingenuity. Keep in mind, this was a time when computers were massive, room-sized monoliths primarily used for basic math. So, naming this brand new field artificial intelligence, that was an act of staggering confidence. This all happened at a legendary summer conference at Dartmouth. McCarthy gathered the absolute brightest minds of a generation, including heavyweights like Marvin Minsky and Claude Shannon, and they came together not just to share academic papers, but to debate how to actually tackle the monumental challenge of creating a mind. The intellectual fervor, the incredible, radiant hope of these pioneers daring to unlock human-like thought. It was just this beautiful moment of boundless, immense ambition. They genuinely believed they were on the precipice of a new dawn, fully expecting to solve the core problems of human intelligence in just a few summers.
Section 3. The First AI Winter, a Crushing Disappointment.
But, as is so often the case when humans reach for the gods, the fall was devastating. What followed their boundless ambition was a deeply melancholic tragedy. Massive expectations were met with a really harsh reality. The U.S. government was pouring millions upon millions of dollars into AI research, desperately hoping to gain a strategic edge in the Cold War. The stakes literally couldn't have been higher. But by the early 1970s, the magical, promised breakthroughs had completely, utterly failed to materialize. The underlying technology had simply stagnated. Let me introduce you to the physical embodiment of their highest hopes. This is Shaky. Shaky was the very first general-purpose mobile robot. He was supposed to be the glorious realization of the Dartmouth Conference's dreams, a bold step toward a synthetic mind traversing the physical world. Instead, with a sort of tragic irony, he became a profound source of deep, agonizing frustration for the brilliant researchers who built him. 1 hour. That is how painfully, agonizingly slow Shaky was. A simple, everyday moving object could cross his path and stop this marvel of modern science dead in its tracks for an entire hour. The computational bottleneck was just massive, parsing raw visual data from a camera and trying to run complex pathfinding algorithms completely overwhelmed the hardware of the era. Shaky would just sit there, circuits whirring, practically frozen in time, just to calculate how to navigate around a block. Imagine the heartbreak of the researchers watching their grand creation paralyzed by the simplest of tasks. This era of crushing disappointment earned a cold, fitting name, the AI Winter. It was a bleak period of severe disillusionment. Funding dried up, hope withered. Those early, brilliant pioneers had to watch their grand, soaring dreams freeze over in a bitter cycle of disappointment. And why this matters to us today is that the trauma of the AI winter still lingers. It's exactly why modern developers remain acutely cautious of hype cycles, always aware that sky-high expectations can suddenly crash right into technological walls. So the crucial point is, Section 4, a haunting question remains: the ghosts of early pioneers. How does this deeply human story of ambition and heartbreak connect directly to us today? Well, as we watch modern AI systems perform tasks that seem like absolute magic, from mastering ancient board games to writing intricate code, we carry the ghosts of those early pioneers with us. And it leaves us with a haunting question. Were those brilliant, hopeful pioneers of the 1950s simply too early, just lacking the sheer computational power and massive data centers of today? Or were they thinking about the very nature of intelligence in the wrong way entirely? It's a question that makes you rethink everything we know about the minds we're trying to build. Thank you so much for joining me for this explainer.
Welcome to this explainer. Today, we're diving into something called the awakening machine, from chess to the code of life. We are going to trace this thrilling, honestly almost unbelievable timeline of modern artificial intelligence. We're talking about a story full of early dead ends, sudden explosive breakthroughs, and a technological awakening that is, quite literally, reshaping our reality as we speak.
So, let's start with the question. What actually happens when a machine learns to think for itself? It's a question that used to belong purely to science fiction, but as we comb through the source material today, you'll see this isn't fiction anymore. We are watching a new kind of intelligence awaken in real time, and the sheer pace of it, it's absolutely breathtaking.
Part 1. The machine that taught itself. To really grasp the suspense of where we are right now, we have to rewind to the very beginning.
Back in the day, human experts tried to manually program every single rule of behavior. They called this the top-down approach, favored by early AI luminaries like Marvin Minsky. But here's the thing, human behavior is just way too complex to hard code. So a massive paradigm shift happened. The radically different bottom-up approach, inspired by the neural networks of the human brain, asked a completely thrilling, almost dangerous question. What if we just let the machines learn for themselves? Now, you might be wondering, if that idea is so great, why didn't it take over immediately? Well, we hit a massive stall known as the 1970s bottleneck. The bottom-up theory was totally correct, but it required vast amounts of data and computing power that simply didn't exist yet. The idea was ready, but it was basically trapped in an era that couldn't physically support it. Part 2. The Transformer Revolution. Fast forward a few decades, the long silence finally breaks, and a single monumental innovation changes everything. Boom! Here is that breakthrough. The Transformer Architecture, introduced by Google researchers in 2017. The magic ingredient here was something called a self-attention mechanism. Before this, models digested information sequentially, one piece at a time. But this new framework? It processed sequences in parallel. By digesting massive amounts of data all at once, that old 1970s bottleneck was finally, permanently shattered. Part 3. Scaling up, the GPT era. With this shiny new transformer engine built, the scale of what AI could do began to grow at a terrifyingly rapid pace. Before we look at the models themselves, let's talk about OpenAI, the organization that built its famous GPT series on this architecture. They were founded back in 2015, and get this, they actually started as a non-profit. Notice their core, original mission was to create safe and beneficial artificial general intelligence for all humanity. Keep that specific focus on safety in the back of your mind as we watch what happens next. Because the escalation here is just astonishingly rapid. In 2017, the transformer architecture drops. By 2018, OpenAI releases GPT-1 as a proof of concept with 117 million parameters. Then, in just 2 short years, GPT-3 arrives, generating eerily human-like text. Each generation was growing exponentially in the blink of an eye. 175 billion. That is the staggering number of parameters in GPT-3 that completely stunned the world in 2020. Just let that scale sink in for a second. We went from a mere proof of concept to 175 billion parameters in roughly 24 months. Part 4. Beyond human imagination. Now here's where it gets wild. The most revealing breakthrough of all didn't actually come from language models. It came from a game board. While those language models were scaling up, DeepMind was over there experimenting with games. AlphaGo Zero and later AlphaZero used this frankly spooky self-taught process. Step 1. Start with completely random play, absolutely zero human rules. Step 2. Teach itself entirely from scratch. And Step 3. Become the strongest player in history. It completely removed human intervention, finally fulfilling that 1970s bottom-up dream. But the true suspense here, it's the time frame. AlphaZero taught itself from scratch to master chess, shogi, and Go in a matter of hours. Literally just hours. It didn't just beat top human players, it beat the absolute best specialized chess programs of the time. Think about that. Games humanity has spent centuries perfecting, dominated by a machine in a single afternoon. And even though chess had been analyzed for centuries with powerful computers, AlphaZero, quote, still discovered new strategies that had eluded human masters. It wasn't just mimicking human greatness anymore. It possessed the capacity to find entirely new solutions that our human minds literally could not conceive. Part 5. cracking the code of life. If you're sitting there wondering why a board game matters, it's because this exact same learning capability was about to be turned directly onto human biology.
Enter the 50-year grand challenge, the protein folding problem. For half a century, predicting how proteins fold was this totally unsolvable biological mystery. It's incredibly complex, yet it is the absolute foundational key to biological science. And then, the silence broke again. In 2020, DeepMind introduced AlphaFold. The exact same techniques that mastered a game of Go successfully cracked a 50-year protein folding problem. It predicted the 3D structure of proteins, effectively mapping the building blocks of life itself. Guys, this isn't just some cool technical feat. It is absolutely crucial for understanding diseases and developing new drugs. AI was now finding biological solutions way beyond human reach. Part 6. Intelligence versus safety. We've escalated all the way from theoretical models starved for data in the 1970s to systems mapping the building blocks of life itself. But this unprecedented, almost unfathomable power brings us to a massive, looming crossroads. So, I want to leave you with this lingering, high-stakes question to ponder as we conclude this explainer. As these systems grow more and more powerful, what happens when the race for intelligence becomes more important than the race for safety? We started this timeline looking at OpenAI's original mission for safe and beneficial AI. But as capability continues to scale exponentially, will the intelligence race outpace safety?
The data streams are showing a clear correlation here.
Wait, the collapse sequence just optimized the entire network. We did it.
All right, let's just dive right into it. Today, we're unpacking an explainer on the absolutely breathtaking pace of artificial intelligence development. And honestly, the stakes have literally never been higher. What we're really talking about here is a ticking clock. It's a global race for superintelligence, and it's moving so much faster than almost anyone fully comprehends. To really wrap our heads around where we are right now, you have to hear this warning from the United Nations Secretary General. We are entirely past the point of passive software that just sits there waiting for you to type in a command. Today's AI systems are writing their own code. They're acting online autonomously, and they are making choices with less and less human oversight. It's a total paradigm shift. We have officially crossed a threshold where our tools are quite literally beginning to operate themselves.
And that technological threshold, it feeds directly into a pretty intense geopolitical reality. The race to build the smartest AI isn't just happening in a vacuum with a bunch of tech companies tinkering away in Silicon Valley. It has morphed into this fierce, incredibly high-stakes geopolitical contest for ultimate supremacy between the world's two superpowers, the United States and China, because both nations view this tech as absolutely critical to their future standing on the world stage.
What's genuinely fascinating, though, is how vastly different their philosophies are in this race. The US approach is basically maximum force. It's about hoarding the absolute best chips, tapping into these massive reserves of computing power, and just pouring in endless capital. It's kind of like engineering a fleet of luxury supercars. China, on the other hand, faces strict hardware constraints, so they're pursuing incredible efficiency. They're designing models to do way more with way less, and making them open weight so developers around the globe can adapt them. Think of it more like mass-producing highly efficient, affordable vehicles. And here is the mind-blowing fact. Despite the sheer raw power advantage of the US, the gap is closing fast. Chinese models built under extreme constraints are now going toe-to-toe with the absolute best models from American heavyweights like Anthropic and OpenAI. But here's where things get a bit terrifying. When a rivalry is this intense, the entire landscape becomes inherently riskier. Researchers modeling this exact dynamic found a really alarming pattern. To fight for supremacy, nations and firms shift massive amounts of resources towards speed. But naturally, that speed comes at a direct cost to safety. Faster development equals a much higher probability of catastrophic outcomes. It's this incredibly dangerous trade-off that nobody seems able to escape. Experts actually have a term for this. It's a collective action problem, and it is a nasty paradox.
See, individual firms might actually prefer a slower, much safer race so they can properly test and red team their systems. But the competitive pressure makes it nearly impossible to slow down on your own. If you decide to hit the brakes to focus on safety, your competitor just blows right past you, and you lose the race entirely. You're basically trapped by the speed of your rivals. Which leaves us to what I think is the most astounding contradiction in the whole AI space right now. We have the leaders of these major AI companies who are simultaneously racing to build these systems at maximum speed while very, very publicly sounding the alarm about the existential dangers of advanced AI. Because they're stuck in that collective action trap, they're warning us about the exact same technology they're rushing to unleash. It's wild. They're essentially building the airplane while it's in a nosedive, all while shouting to the rest of us about how dangerous the crash is going to be.
So, let's talk about the countdown to artificial superintelligence. Exactly how much time is left on that ticking clock we talked about? Well, 50%. That's the number. According to aggregate forecasts from top researchers right now, there is at least a 50% chance, a literal coin toss, of AI achieving artificial general intelligence milestones by the year 2028. Let that sink in. We aren't talking about some distant science fiction scenario in the next century. We're talking about human-level capabilities in just a few short years. Just think about the whiplash of how fast this is moving. Back in the 1950s, computing pioneers were merely dreaming of thinking machines. Fast forward to 2028, and it's a 50-50 shot we hit AGI. And by 2030 or 2031, current predictions point to the emergence of artificial superintelligence. We're talking about machines that will surpass all human intelligence combined. That is a frighteningly short jump from rudimentary computing dreams to technology that entirely outpaces the human brain. When you step back and look at the whole picture, you realize this isn't just a competition between tech giants anymore, or even just a geopolitical chess match between the US and China. Ultimately, what we are watching is a race between our capacity for creation and our capacity for wisdom.
And if you take nothing else away from this explainer, let it be this. The question of whether we can build machines that outthink us, that's been answered. We are doing it right now. But while the smartest intelligence in the world may very soon be artificial, the burden of wisdom absolutely has to remain entirely human. We have to be the ones stepping up and guiding these unbelievably powerful tools we've created.
Which leaves us with one final, incredibly chilling question to ponder. As that clock ticks down and the crushing competitive pressure forces companies to prioritize speed over safety, the question is no longer if we will build these superintelligent systems. It's whether we can build them in time to also build the safeguards that will keep us safe. It's a lot to think about, for sure. Keep asking those big questions, and I'll catch you next time.